Hello, this video is a demonstration for a Perlin noise ocean surface rendering and animation. What you see in front of you is a somewhat visually sensical ocean surface, and that's because of two main features. One, as was implied a second ago, the noise. You see somewhat randomized surface, bumps, whatnot. Um, the second is local coherency. Um, so combining those two elements to generate this kind of surface procedurally is the main goal of this project. So this particular implementation was built in the processing environment, um, a Java-like 3D environment for those that are unfamiliar. Um, and in the course of implementing it, uh, great source was used. It's the Perlin Noise Math FAQ by Matt Zucker. Uh, pretty pretty straightforward Google search. Uh, Turned it up. Um, but yeah, so it's implemented as follows. On the screen is a 64 by 64 vertex grid. Uh, each vertex represents a particular height in the ocean surface, and those values are generated from the noise function that was built based on some of the recommendations in that write-up. Um, and that noise function is taken from to help visualize like a superimposed 8 by 8 lattice that sits in the same space as the 64 by 64 vertex grid, and the intermediate vertexes uh, interpolate their height positions from the uh, from the vertexes in the grid, um, and specifically the vertexes in the noise grid were each assigned a randomized and normalized 2D vector, and the heights of the vertices were interpolated from the quad of randomized vectors. Um, so what you get is, in the end, is this sort of bumpy surface with the local coherency. You see at the bottom left here, there's some bumps. Um, but you'll find that if you were to examine this, the local coherence only exists within 8 by 8 quads, which makes sense because it's how it was generated. But uh, one of the one of the very simple and cool features of this procedurally is that to get it to animate, which spacebar, get it to animate. If the noise points for the result, the rendered grid, are wrapped around each other, where uh, the final quads at the edge of the surface um, interpolate their values from the final points in the noise grid and the first points in the noise grid. You get a nice smooth transition from end to end. Um, and there's a few different ways of doing this in a straightforward type capacity. Uh, you can randomize in each time step. Sort of intuitively want to think that's inefficient. So that was an avoided approach. But something more simple definitely gave a good look for the ocean here. Um, and with some different rendering effects, this kind of surface is suitable for a lot. Um, yeah, so that's the meat and potatoes of this project. If you have any questions or are interested, please don't hesitate to reach out. And thanks for watching. All right, bye bye.